Okie doke. So, I wanted to start off with doing a little bit of scientific notation practice, because I did see some students were struggling with that on the quiz, and it's super important that we get that down. So,
quick question, are we going to be able to see what we missed on the quiz? Can't we?
Can you not?
Last time I checked, but let me check right now.
We weren't, when we finished the quiz, at least when I finished it, we weren't able to see the answers we got wrong or the answers we got right.
So when you first finish it, it won't be open, but as soon as I'm done grading them, I open them. So yeah, you should be able to see that now. Yeah, cool. Thank you, Rochelle. Yeah, so Rochelle's saying that you guys should be able to see that now. Okay, so I'm starting off with the worksheet for this week, the SciNo and dimensional analysis worksheet. And just for those of you who weren't in my preamble earlier because you're watching the video, I'm not going to go through any more of the dimensional analysis questions today because I want you guys to be able to work on those on your own. I'm going to go through scientific notation and some more problem-solving techniques. So whatever's left over, I'll have answer keys up later on today, Friday. Okay, so.
Sorry, quick question.
Go ahead.
I'm looking over the quiz.
Yep.
And for one, I put 2 decimal points in there, which I don't even know where that came from. The answer is incorrect because I did 10 carat.
Yes. Yes. Yeah. Yeah. So this is because I gave 5 bonus points to everybody. I was kind of hard line about the notation. But generally speaking, is it like the biggest of deals? No, but it just makes it a lot easier for me if you guys put it into the notation that I ask you to. Does that make sense?
Yeah.
Yeah. And we'll talk about how to do that here too. Okay, so when putting something into scientific notation, I think that the most important thing, is to recognize the relative size of your number, right? So is this number a big number or a little number?
Big.
It's real big, right? So if we have a really big number, then should we have a positive or a negative exponent?
Positive.
Positive, exactly, right? So first things first, we're thinking this is going to have a positive exponent. So we have an invisible decimal place here. Move over 1, 2, 3, 4 places. And so we will have 1.92 times 10 to the 4th, right? And on a quiz, you would be writing this like this, right? And that's just a limitation of Canvas because it doesn't allow you guys to do superscripts in your answers, which is super annoying to me as an instructor, but it is what it is. Questions about that one? Cool.
Oh, Professor, sorry, I have a quick
Yeah.
question. So when we say in the quiz and we have to show work, do we have to show work for that, or can we just show work for the ones that need to show work?
For something like that, I wouldn't need you to show work. I know it's kind of weird right now because we're going through material where there's not a whole lot of work to show. The dimensional analysis will be the exception to that, right? So once we get into problem solving with dimensional analysis, there's not just a point for the right answer, right? A lot of the times these problems will be worth 7, 8, 9, 10, 11 points. And the vast majority of those points are not for getting the correct answer, right? They're for showing me that you can set things up correctly, giving me the correct units, having the correct order of magnitude, right? So sometimes you might get the right answer, but you have, you're off by like 1,000. So that kind of stuff, I give a lot of partial credit there. So that's when it becomes really important to show as much work as possible, right? For something like this, if you were to put like -4 here on accident, I know that you've mixed up when to do the negative and the positive for this, right? So there's not really any way to give partial credit for that, because that is just part of knowing how to do scientific notation. So does that make sense?
Yes.
Yeah. So long story short, basically, is there'll be plenty of opportunities to show your work going forward. But if it seems like it would be harder to show your work than not, then don't worry about it.
Okay, thank you.
Yeah. Okay, so now, small number, big number.
Small.
So small, right? So when we do this one, it's going to have what kind of exponent?
Negative.
Negative. 1, 2, 3 places we're going over here. So we'll end up with 8.92 times 10 to the -3, which would be 8.92 e to the -3. Questions about those guys? Okay, so I think one of the things that I find students struggle with, so I think this way is easier when you're starting off with a number and you're going to the scientific notation. I think when you start off with scientific notation and you have to take it out, I think that's usually when people get tripped up, right? So let's look at a couple of those. I'm going to skip around a little bit. So, looking at this guy, big number, small number. It's a little guy, right? So if we know that there's a negative exponent, we know that this is going to be a small number. So we can, if you like to do the decimal moving over this way, you can do that, right? But for this one, I'm just going to rewrite it to make it less messy. So basically, if I know I have a -4 here, I know that one of the decimals that I go over is going to be for the 1, and then the rest are going to be zeros out front, right? So 1, 2, 3 zeros, then my 1, 8, 3, 9. Does that make sense, guys? So however works best for you, do it that way, but that's how I think about it. Mostly because having all these zeros out front can get really confusing. That's why we write it in scientific notation in the first place. So I'm always trying to make sure I have the right number of zeros out front. Okie doke. Questions about that one? Okay, so now I want to look at a weird example. The weird examples usually trip people up. So, how to put this number into proper scientific notation. First of all, why is it not in proper scientific notation?
Because the decimal isn't only 1. You know what I'm saying?
Yeah. So there's
one in front, yeah.
So for proper scientific notation, we should only have one non-zero digit in front of the decimal place. Yeah, totally. Is everybody okay with that? Cool. So now the question becomes, am I making this exponent bigger or smaller? Smaller, right? So if this is a big number, right, and this is a tiny little exponent, right, then by moving this decimal place over 1, we're going to get -2 for our exponent. Is everybody okay with that?
Yes.
Carlos? Did you just get, you could the look of anguish on your face? No?
Yes, I see that.
But it's really hard to see, okay, guys? So this is, I would say, probably the hardest type of problem, is having to go to proper scientific notation when you have scientific notation, but it's just not proper, right? Because then it's like, which way does this exponent go? So 25 being a relatively large number, and this guy being a small exponent, when we absorb that extra power of 10 into here, right, it's going to make it less negative. So we'd have 2.56 times 10 to the negative 2, right? But that is definitely not easy to see. So let's do one more of those, because I think they're tricksy. 53. All right. So, what do you think is going to happen to our exponent with this one?
Would it increase?
It's still going to increase, right? So here, the power of 10 is 4, right? But now we're going to add another power of 10 in here, right? So when we add another power of 10 in here, that's going to make this 5.31 to, oops, not negative, to the 5th, right? So I think it's easier to see that this is increasing than this, right? Because we're getting less negative, that's technically increasing, but the digit is decreasing, right? So that's usually a source of confusion for students. This isn't something you're going to run into too often, but I think getting this flexibility and practicing with scientific notation is really helpful for starting to understand what the heck it is conveying to you. Did you have a question, Sadie? You look angry.
Yeah, sorry. Like an example like this where we're going to be subtracting.
Do I have one of those on the worksheet? Let me see. Beep, boop, beep, boop. Not in sino. Let me see if I have one on the other one. I don't have any examples like that. Let's just make one up. Let's just do it. So, new example. Let's say we have 2.56 times 10 to the negative 3 minus 3.4 times 10 to the negative 4. Yeah. Okay, so this, without putting it into a calculator, and if you're not confident about scientific notation in your calculator, then you might mess this up. This is a hard problem, okay? I probably wouldn't give you something like this because I think this is a difficult problem, but I think it's a good exercise for us to just talk about so that you can see how this would be done. So, first of all, do we expect this to be a positive or a negative number when we subtract?
Negative.
Which one of these numbers is bigger?
First one. That one.
Yeah. So this one is bigger. This one is smaller, right? You guys see that? So,
is it because of the negative 3?
yes, so negative 3 is a less small exponent than negative 4. Does that make sense? Yeah. And
Okay.
I think that this is really helpful, right? Because when we talk about big and small, we're talking about the relative size, right? So relative, they're both small numbers, but relative to each other, this one is 10 times bigger than this one, right? So having an instinct about what to expect in your answer is the first step to hopefully getting it right. Because if you expect a negative number here, then you're going to second guess yourself when you don't get that, right? Cool. So there's two ways that we can do this problem. The first one would be to get them into the same power of 10. Oops. So what do I mean by get them into the same power of 10?
Wouldn't you write out the full number out of scientific notation?
That's one way to do it. There's multiple ways, but I'm starting off with this one, which is get them into the same power of 10. Sorry, I'm not looking at the chat right now.
Would you just move the decimal?
Yeah, basically. So if this guy is in 10 to the negative 4, right? It's going to be a lot easier to do this math if we get this guy into 10 to the negative 4 as well, right? We could also get this guy into 10 to the negative 3, right? Doesn't matter which way we do it, but as long as they're in the same power of 10, then we can do simple addition subtraction maneuvers, okay? So if I want this guy to be in 10 to the negative 4, which way do I want to move this decimal? To the right. Everybody all right with me on that? Cool. So now I'm going to rewrite it up here. So I've got 25. Question?
Doesn't that take it off proper scientific notation?
It does, yeah. But we can always put it back.
Okay.
Yep. So now I can subtract this number just by lining up my decimal places. Right? I don't need to do anything with the power of 10. It's just going to come down here, right? All I need to do is 25.6 minus 3.4. 2, 2, 2. Yeah? So then if I wanted to put that back into proper scientific notation, what would I do?
You move the decimal over
To the
left.
Beautiful. And what's that going to do to my exponent?
Negative 3.
Negative 3.
Negative 3, exactly. Is that Yvonne? Did you get that right in the chat?
Yeah.
So pretty! I love it. So, again, it's not super difficult, but if you're not confident with scientific notation, it's really easy to mess this up, right? So, I want to do it in the calculator because I think that's probably the easiest way to do it, as long as you know how to use your calculator. So I've got 2.56 secondary function EE negative 3 minus 3.4 secondary function EE negative 4. Huzzah! If I want to put that into scientific notation, second, psi, enter, and there we go. We did it. Questions about that one? That was a great, I think that's a great exercise, Sadie. I'm glad you brought that up because I think it helps you get more flexibility with that side note.
You're welcome.
Anybody else have questions about that? Okay, I'm gonna stop the video here.